Okay guys, welcome back to the IPC Flip Classroom. Once again, I'm Mr. Hawkins, and today we're going to be discussing physical and chemical properties. Last time we kind of got the feel for matter, right? States of matter, how matter tends to exist in our natural world. Now today we're going to get a glimpse of what it actually looks like, okay? To do this, we need to know a lot about physical and chemical properties. Remember, each state of matter has its own different types of characteristics, and that they are all composed of atoms, and they're arranged in those different ways. Remember, the solids had that really tight arrangement. Remember, in liquids, it was a little bit more wobbly, right? They could flow because it was becoming a fluid. And then whenever they get into gas, they're bouncing off all the walls. So there's all different types of matter and different types of arrangements in that matter, okay? And these differential types of compositions and what things are composed of and how these different atoms interact with one another all lead up to different physical and chemical properties. So first of all, physical properties. These properties are easily determined without changing the identity of a substance. So these are things that you can just see on the face, okay? For example, I'm drinking Canada Dry Ginger Ale. As you can see, whenever I pour it out, it has a yellowish tone to it. It also produces bubbles, okay? So properties that happen without changing anything going on in it is actually a physical property. So it's in a green can, okay? The green can is made of aluminum and it makes a noise whenever I flick it, right? Okay, so we can also have different types of physical properties. They can exist in extensive or intensive quantities, okay? So extensive physical properties depend on the amount of matter present. We're going to talk a lot about these here in just a second. But intensive properties are commonplace, okay? Every type of the substance in any form, no matter how much, no matter how little, will have these same types of properties, okay? So what's the difference between extensive and intensive, okay? Extensive, once again, depends on how much of it there is, okay? And that is things like mass, volume, length, and shape, okay? So we learned how to measure mass, volume, and length the last unit. But in this unit, we're also going to carry those over. They're extensive physical properties. And also the shape of an object is something that ties into an extensive physical property. This matter is arranged in a bowl-like shape, okay? Intensive properties, things like color, taste, smell, melting point, boiling point, luster, hardness, buoyancy, and viscosity, okay? None of these change the chemical makeup of the thing. It's just something that you can notice, okay? Boiling point is kind of tough there, okay? So is melting point. But as long as you're not creating a chemical change, which is oxidizing it or making it combust, okay, you're not implementing that. It's only a physical property. Luster and hardness. Luster goes into some types of metals and also some types of minerals, but that is how shiny something is. So this can would have a metallic luster, okay? Hardness. This bowl is very hard, okay? Hardness is a property that you can test using scratch stones. You also do it a lot in geology. Buoyancy and viscosity are another type of physical property that we're going to discuss a little bit. Viscosity is the resistance to flow, okay? So we have things like honey that fall into this. Some oils are a little bit less viscous than water is. Once again, color, taste, smell, how something sounds even is all different types of intensive physical properties because it does not matter on the amount of the stuff there, okay? Now, chemical properties, on the other hand, they can only be determined by changing the substance's molecular structure, okay? So that means making it undergo a reaction is the only way to know chemical properties of a substance. Reactivity with another substance is one of these examples. Okay, so if we take sugar and mix it with sulfuric acid, it has a very vigorous reaction and turns into those giant black snake firecrackers, right? Then we also have pH. pH is how acidic or how basic something is, okay? So acidic things like Coke or lemon juice fall into acidic categories, and things that are basic like milk or other things like that that's an example of a chemical property. Flammability, okay? So if I take a piece of paper and I light this piece of paper on fire, then that is an example of something being flammable, okay? But I have changed the molecular structure of that paper. Toxicity. Certain substances are very toxic to humans. They're also very toxic to animals and things like that. That's a chemical property because it's being ingested and reacting with the stuff in our stomach, okay? So once again, physical properties are simply things that you can notice. They can be determined on what it is in the first place or how much of it there is, okay? And then we also have things like chemical properties where you have to react it. You have to cause it to go into chemical reaction to notice these types of things. Okay, so my Iron Man fans out there, we're discussing physical and chemical properties today, and what I want to discuss to you is vibranium, the element that Tony Stark derives in the second Iron Man movie. As you can see, this is an image of the vibranium that he puts together in the movie. And let's say if it did exist, it doesn't technically exist, but in Marvel Universe, we'll say it does. And so if we were there, what would be some chemical and physical properties of this thing? Well, what we're looking at specifically is inside the inner triangle, that bright white color. That's going to be the vibranium in this. The rest of it's just a housing. So things that we could see. It produces light. That would be what? Chemical or physical property? Actually, a chemical property, okay? It's a white color, however. That would be a physical property. We also have things like it's got a lot of energy coming out of it. That's a chemical property. It's unstable. That's a chemical property also. Physical properties are a little bit harder with these imaginary elements, but as you can see, it gives off a bluish tint on the outside. It's probably very, very hot to touch. The boiling point, melting point, I'm not even going to be able to tell you. I doubt any person from Marvel could tell you either. But as you can see, also, this vibranium is the same stuff that makes up Captain America's shield, right? So it can be malleable. It can be turned into silver. It can be made into shields, okay? It's also very strong, very durable. It has a high luster to it because Captain America's shield is real shiny, right? And other than that, that's just a few of the many examples that you can see with this stuff. I know it's being used as an energy here to power Tony Stark's magnet in his chest, right? Anyway, this is an imaginary example about something that's very true in our lives, okay? We have physical and chemical properties everywhere around us. And yeah, if you guys need further assistance with chemical and physical properties, please come in for activity period. Don't be shy. Also, post some questions in the comments feed. That's always an option. And ask me some questions tomorrow doing Q&A. If you have any other questions, guys, that's all I need from you. Have a great evening. Thank you guys for logging on.